Greetings class and welcome to week 10. This week in 4710 we're going to talk about sniffing. And this course is going to primarily focus on two applications, TCP Dump, which is the foundation for any sniffing program, and Wireshark, which is a wrapper that uses the core of TCP Dump to collect data from a source. And we're going to talk about sources of data, which basically we're going to collect Ethernet frames and raw data off of the network or from systems. And we can look at that data in forms of frames, packets, and information all the way up to layer 7. So let's get started. So we're going to look about what packet sniffing is, how we use TCP Dump and Wireshark, and how we set up for a very robust sniffing environment at the network layer. So, what is packet sniffing? It basically is a way for you to capture packets, frames, for decode and analysis. It typically works only with clear text or decrypted packets. If we can still pick up some information that is not encrypted, typically Ethernet headers, but past that, it's difficult if we are looking at encrypted traffic. So keep that in mind. The network interface typically is only going to forward frames up to the operating system. If the frame is addressed to the interface, i.e. the MAC address, it will also get picked up as well. In looking at that, all frames that the interface card sees, the interface needs to put into a file called a PCAP. And a PCAP file is just a collection of all those frames for a certain amount of time. This is typically called promiscuous mode when we can collect that. We only typically use an interface in promiscuous mode as a collecting interface for this type of data. Those types of interface cards do not have an IP address. They'll have a MAC address, of course, but that's it. They're just there to collect data. Historically, this required specialized network interfaces and drivers, not necessarily anymore. In wireless, it still does. Your chipset in wireless has to be able to let you put that interface card into promiscuous mode, so you can not only sniff traffic anonymously, but you can also inject frames. A frame is the protocol data unit layer at layer 2. It's typically what we call an Ethernet frame, but it could be a PPP frame, HDLC frame. It just depends on what layer 2 protocol you are using. And we're capturing the packet, typically is the common terminology or nomenclature of that. So again, what is promiscuous mode? Every frame that passes by the interface gets collected and sent up to the operating system. MAC addresses are physically burned into the interface card, and again, this is going to require us to have privileges on the system in order to set the interface into promiscuous mode in order for it to collect data. Also, the chipset on the network interface card must be able to be put into promiscuous mode in order for this to work. A driver has to support that, and that's how we can tell. So that's why there's a limited number of wireless cards, typically they're external wireless cards, that have a chipset that will allow you to do that. Most all modern wired cards will allow you to do that. That's not a problem. But we still have to be able to send traffic to the card, which we'll talk about later when we talk about putting switch ports in mirror mode or SPAN, switch port analyzer mode. So the software that we use for this is typically going to be TCP Dump or Wireshark. And these are specific programs written in order for us to collect data with all this information on frames and headers and everything else. It helps us to display this graphically so that we can understand it logically. It may also decode packets to show additional detail within the data portion of the packet. So how do we use TCP Dump? Well, very simply, it's a common command line utility. It comes in pretty much every distribution of Linux. You can get it for Windows with specialized programs and applications. It displays a summary of header information for IP, TCP, etc., and can display additional information when you ask it to be verbose. You can also use it in conjunction with the tail command in order to dump TCP data into a PCAP file in order for you to analyze it with additional tools later on. But you can also see all of this in real time if you use the verbose methodology. I'm on a Windows system. I am not in a Linux system, so I really can't show this to you right now, but it is a pretty easy command to use, and it depends on where we're collecting the data from. Wireshark, on the other hand, is a GUI-based program. It can be run in Mac, Linux, Windows. It uses software based off of TCP Dump. It understands protocols and visually lets us see those protocols broken down. This is even true for protocols that are in binary and even not in plain text that are encrypted. It has a lot of statistics capability. It allows you to massage the data that you collect greatly. It has a lot of filters for you to help you with network troubleshooting. I love using Wireshark when there's a network problem, because if I can get to the source of the data and analyze it, I can use Wireshark for that analysis. I can capture data over a period of time and then go back and look at it at my leisure. It's a very powerful program, and all network engineers and system administrators really need to know and understand how to use it. On the security side, it is also really great because if you can collect these data in PCAP files, you can study it for later and potentially pick off certain types of criteria, such as a password file or a hash or something of that nature. This only becomes available in a switched environment where we are able to see a very broad area of data across many different ports or even VLANs. And a switched environment is going to ensure that only frames addressed in this fashion are observed. Hubs, on the other hand, are very simple devices that allow us to see all the traffic going across the device itself. And we do not have to address these devices, either the switches or the hubs, at layer 3 in order for them to work. So how do we get that to work? Well, a hub is automatic. We just have to plug everything in and then watch the traffic come in. But a span port is a special type of port that allows us to dump information to a single port or to a single device, i.e. a laptop or a PC. Cisco pretty much defines this as a switch port analyzer port. A lot of other vendors call it a mirror port. And this is where we can set up a port to monitor 1, 2, or dozens of ports, and then take all the frames that are going across that port, inbound or outbound or both, and then dump those frames to a specific port's transmit buffer to the collector. We can also span this not just across ports, but across entire VLANs on the device as well. But the typical appropriation here is that it has to be at layer 2. So let's cheat. We don't need to involve the network engineers. We can tell everyone on the network to just send traffic to us. No, really, we can. With a span port or an RSpan port, we can do that and then just sit back, collect the data, and set up scripts for analysis. So spoofing is one way that we can do this as well, where we can spoof a MAC address or typically an ARP address at layer 2. And we can send ARP responses without any type of a request in order for another station to trust us. Ideally, we present this to other systems to fool them into thinking that we are somebody else. Okay, so here's a problem that is typically seen where you're pretending to be somebody else who you're not. So you're pretending to be Bob, who's talking to Allison, another state. Alice sends Bob a message that Bob is expecting, but you're telling everybody that you're Bob. Guess what? You're really not Bob. Bob doesn't get that message. Bob starts to suspect something. Alice starts to mistrust Bob. The world falls into chaos. So this is a typical problem with spoofing, where you can actually do a lot of damage at the human layer and imposing a lack of trust. So here's the answer. Forwarding. If you enable forwarding on a system, you can capture and send back out the correct recipient, and you can validate yourself. So this is where things such as non-repudiation digital signatures really come into play. And all the world will be better off if we did that. A lot of different types of security practices such as multi-factor authentication, digital signatures, things of that nature are very important for us to be able to trust our identity of others and have others trust us. So, in summary, packet captures are the process of collecting and completing frames. Packet capture software includes things such as TCP Dump and Wireshark. Switches prevent all traffic on the network from being seen. A switch port, analyzer port, or mirror port can be used to collect data across multiple ports or even whole VLANs. And you can also use techniques such as spoofing in order to masquerade as someone else to get additional information. So, very short lecture this week on sniffing. In the course, just a second, let me get the syllabus up here. So we're in week 10, and this week we have homework 4 that is due. So I'll go over that in a separate post. And that's about it. Lab 3, we should be pretty much in full swing with Lab 3. I don't have I have a due date of week 15 for Lab 3, so you got plenty of time for it. So that's going to do it for this session. This is Professor Brown signing off. Have a great week.